Ever wonder what happens when the Earth shakes? I mean, really shakes? We're diving into the science behind earthquakes today, specifically the 2022 Luding earthquake in China.
It was a big one, a magnitude 6.8, quite a powerful event.
Powerful is an understatement. This paper details a really cool data set they put together. It's pretty neat.
Yeah, it's not just about the shaking itself, but also about the ground it's shaking on. That's a key point.
Exactly. They looked at PGA, PGV, and something called VS30. So what are those exactly?
PGA is peak ground acceleration, how hard the ground jolts. PGV is peak ground velocity, how fast it moves. Think of it like the difference between a quick punch and a strong shove.
So PGA is the intensity and PGV is the speed of the shaking.
I see. Precisely. And VS30, that's the average shear wave velocity of the top 30 meters of soil. It tells us how the ground will respond to the shaking. It's important stuff.
So this data set is like a snapshot of the earthquake's impact, right? They collected data from a bunch of different sensors.
Exactly. They used accelerometers and MEMS sensors, a mix of high-tech and more readily available tech, over 800 recording sites in total. Wow, that's impressive.
Wow, that's a lot of data. And it's all publicly available?
Yes, but with a little registration process. They want to make sure it's used responsibly. Understandable.
What were some of the key findings from this massive data set? Any replicating shakes?
Oh, yeah. The maximum horizontal PGA hit 634.1 gal, and the PGV reached 71.1 centimeters/s. Pretty intense. That's significant.
Whoa. And what about the ground itself? Did that play a role?
Absolutely. Over 80% of the recording sites were on soil, not rock. Soil amplifies shaking, making it more dangerous. Makes sense.
That makes sense. And this VS30, how did they figure that out for all those sites?
They used a combination of direct measurements and a new model they developed. It combines existing data with topographic slope to get a better estimate. Clever approach.
So they weren't just relying on existing models.
No, they compared their new model to existing ones like the Walden Allen model. Theirs performs significantly better in this region, a big improvement.
So their model is more accurate for this specific area?
Yes, it seems to be. They validated it using data from sites where they had direct measurements of VS30. The results were pretty good. Good validation.
So they had a way to check their work, which is always a good thing in science. Very important.
Absolutely. Transparency and validation are crucial. Completely agree.
So where can people find this data set?
It's available online at a website they mentioned in the paper. It's a flat file, easy to work with, easy access is great.
And what's next for this research?
They plan to improve the data set further. More data, more refinement. It's an ongoing process, always room for improvement.
So this paper is a great example of how detailed data sets can help us understand earthquakes better. A valuable contribution.
Absolutely. It's not just about the big numbers, but also about the context, the ground conditions, the sensor types, and the model comparisons. The context is key.
That was a great discussion. Thanks for sharing your expertise. My pleasure.